This is joint work with my student, Nora Dillon, who's at Arizona State University. And we're going to talk about the consequences of academic match between students in college. You'll notice that the title has those of you who have seen this before, which are a couple of people in the room, the title has changed. Our friend Sarah Turner is on a crusade against the term mismatch, a crusade that I have some sympathy with. The concern is that mismatch has a sort of normative connotation that we do not want to convey. We just think of this as a very positive exercise of sort of learning about the production function of academic and labor market outcomes. And one interesting aspect of that production function is the interrelationship between the quality of the student and the quality of the college to which they attend. No normative content should be assumed here. And the academic part, as opposed to the match rather than mismatch, is to emphasize, and I'll come back to this in my concluding remarks, that one could imagine other dimensions of match. Those have not really been studied by economists. I think perhaps they should be. But we are focusing here solely on what I want to call academic match. All right. First of all, it's important to define overmatch and undermatch. So overmatch is a weak student at a good college. Undermatch is a good student at a weak college. If you look at the history of this literature, there's a long literature on college quality that goes back into the 60s, actually. People looked at the Determinant data and old things like that. That literature is largely forgotten if one reads recent papers, which I think is too bad. The mismatch literature really only goes back, say, 15 years or so. And originally, it was preoccupied with overmatch, particularly overmatch due to affirmative action. So relatively underprepared students ending up at high-quality institutions. And maybe we're actually not doing them a favor if they're not prepared enough to succeed at those institutions. More recently, in part because of this book, Crossing the River, by Bowenbach and Chingos, interest has turned away from overmatch to undermatch, which is sort of good students who are not ambitious, it seems, for whatever reason, and end up at schools below those which they might potentially get into. We're going to discuss both of those things today. This research is also both this literature and my own work in this literature. I go back now quite some time, and you'll hear various references to my earlier papers on college quality as we go along. There's also an earlier paper on mismatch, or match, about the determinants of match. And I'm going to start off by saying, kind of giving a summary of that, because that's where we start from in thinking about what we will argue is the causal effect of match. We're going to be circulating a lightly modified version of what I circulated for the seminar as an IZA working paper soon. We got a little bit scooped on our last paper. We are keen not to be scooped again, so we want to use our privileged positions as members of the IZA to assert property rights. So we'll see how that goes. All right, what did we learn in the first paper that we did, the determinants of mismatch? We learned there's a lot of mismatch, and I will show you the descriptive statistics on that as part of this presentation. We learned by comparing our results, we're going to use the 1997 cohort of the National Longitudinal Survey of Youth in this paper, as we did in our previous paper. By comparing our results to earlier work I did with Dan Black and Kermit Daniel that used the 1979 cohort of the National Longitudinal Survey of Youth, we come to the conclusion that mismatch is relatively stable across cohorts, perhaps surprisingly, given that we have all this recent policy interest. It seems like the underlying phenomenon has been present for a long time. There are other papers out there using other data sets that disagree with this conclusion a little bit. This is a place where additional research would be actually useful to sort of make sure that we're confident we're doing apples to apples in our comparison with the earlier work on which I was a co-author. It's not so clear that these other papers are necessarily always doing apples to apples, so that would be useful. I will show you a bit of this too. The literature with which we concur argues that in approximate sense, most of what this academic mismatch is driven by student behavior rather than by college behavior. And I will show you a table that illustrates that for these data. Geography matters. People are more likely to go to a school where everybody else looks like them in terms of academic ability, or where the average student looks like them in terms of academic ability, if they can do so without going very far away from home. That turns out to matter. And we conclude, and I don't want to push this too much or too little. This is sort of conclusion using proxies, but there are several of them, and I think we can make a case that this is part of what's going on, is that parents believe that mismatch is not empirically important. They act like we should just always go to the best possible college you can. More informed parents, their kids end up at better colleges and not worry about the effects of mismatch. So one can view this second paper as, are those parents right? Are those students and parents right in their beliefs about how the production function works? So this is from our other paper. This is some evidence for the NLSY97 cohort. And one weakness for this purpose of the NLSY97, which is otherwise a very nice data set, is that they only got data on the colleges that people applied to for a subset of the data. Now, it's an OK subset. It's defined by year of birth, so it's in that sense exogenous. But there's a bunch of birth years, right? The NLSY97 sample is people born in an interval, and they only get part of that interval. I don't know why. Seems like a bad idea to me. So share of mismatched students who didn't apply to a good match, among the overmatch, 67%, among the undermatch, 69%. I'll explain exactly how we define match as we go forward. For the moment, just go with me. Applied to a good match but didn't get in, not so many. Were accepted to a good match and didn't attend, around a quarter. So this is the sense in which, in an approximate sense, right, it's up to the students. The students could have applied or accepted differently in a way that would have led to less mismatch as we are going to measure it. Who cares? Who cares? Why are we doing this? What's our motivation? Well, part of the motivation was that it seemed puzzling to me when I read the shape of the crossing the finish line. It was puzzling to me that there didn't seem to be any effects of mismatch on completion of college, right? Students who go to good college seem to complete, no matter how good they are when they come in. Students who go to bad colleges seem not to complete, no matter how good they are when they go in. That seemed surprising to me until I read this story in the Ann Arbor News. It was kind of an expose of the classes that our student athletes take at the University of Michigan, and particularly student athletes from a couple of major revenue-producing sports. And it turns out that there are sort of classes just for them that are taught by people who are known as friends of the athletic department. And for example, many of our football players learn a particular Native American language as part of their academic career at the university. And my colleague Charlie Brown commented that what the university's response should have been was, this is the language they use in the huddle, so that the other team doesn't know what they're saying. The athletic department was not smart enough to come up with that story, but I thought it was a good story. But the serious bit here is, in a big university, like Michigan, like Stanford, there's many paths to the finish line, right? And some of those paths are challenging, some of those paths are less challenging. And so maybe it's not surprising that there are not effects on completion if, in fact, the institution is flexible enough that it can find a way for students of low ability to succeed and can find a way for students of high ability to succeed. I already said that. There's policy interest here. I think that's pretty obvious. And then there's a broader question about sort of how human capital production works. There's a parallel literature. I was talking about it with somebody today about sort of match between students and teachers in primary school. Right? Are there some teachers that are good with stronger students and some teachers that are good with weaker students? These are issues that are of interest for sort of obvious reasons of how you want to run the system. Very selective literature review. There's a lot of studies that use selection on observed variables to try to get at the effect of college quality. We're going to be using selection on observed variables to look at the effects of mismatch. I'm going to try to make the case as we go forward that, well, selection on observed variables always has a bit of an odor to it. We're always a bit concerned. What about the unobservables, or at least the unobserved things? I try, following Duncan Thomas' remark at a seminar a few years ago, I always try to say observed and unobserved instead of observable and unobservable, because what is observed is endogenous to the researcher's decisions. And it's good to keep that in mind, I think. So these are my older papers on college quality. That's Black, Daniel, and Smith. This is the Shape of the River book. This is the Crossing the Finish Line book. This is a paper by Mark Long. There's a couple of instrumental variables papers. This paper actually is an early paper that looks at mismatch in the Journal of Labor Economics, early 2005, 10 years ago. Peter Arcidiacono's paper. The institutional environment here does not provide a lot of instruments that leap out at you as being really compelling. I would argue the instruments in these papers are not so compelling. But in part of the joy of higher ed relative to K through 12 is that there aren't always a lot of discontinuities sitting around. There aren't always a lot of random assignment to be had and so on and so forth, and so you have to work a little harder. The outlier in the college quality literature is the Dale and Kruger papers. And this is not the place to go into critique of the identification strategy in Dale and Kruger. I know there are people here who thought a lot about their identification strategy. I hope to write a whole paper, actually, thinking about their identification strategy. See if I can talk Nora into doing that or not. Problem is we can't do it with MLS 197 because of the not having the application data for everybody. Recently, there's a couple of very nice RD studies. I guess Seth was just here this week. This is Penn State. This is a directional school in Florida, I believe. This is really interesting. And it's been interesting for me to watch how the Hoekstra paper has played out in sort of the popular highbrow media relative to the Dale and Kruger paper. So the Atlantic magazine has a higher ed issue every year. And it used to be only ever cited the Dale and Kruger paper. And they said, oh, you silly parents, you should quit worrying about college quality. It doesn't matter, blah, blah, blah. Dale and Kruger, Dale and Kruger, Dale and Kruger. Now they have to pair it with Hoekstra. They're not willing to cite any selection on observed variables papers because we know that's all rubbish. But they're willing to cite Hoekstra, which is very compelling and finds very large effects of being on the margin of admission to this unnamed flagship university that's probably Penn State. And that's interesting for mismatch too, right? Because remember, the RDS demand is the treatment effect on the people right at the margin. So this is the weakest students who get into Penn State compared to the people. Pardon me? Oh, it's Florida?
Yeah, that was my understanding.
Oh.
But
now I remember that he.
Because it's not recognized in the paper. Oh, yeah. So
all right.
Penn State South, Florida.
All right. I remembered that he was at Florida. I don't know why. I thought, oh, well.
Because
he was at Pitt.
Pitt.
All right. All right. Silly me. Okay, Florida.
Well,
he's a student of Figlio's, right?
Do we believe Eric?
He's a serious guy.
Yeah, he's okay.
Okay. All right, Florida. Anyway, in any case, it's the weakest students who get into Florida and then the best students who get into whatever the next thing down is. And it's a kind of muddy alternative since those people go in a lot of directions. But the fact that you get a big impact there is at least not helpful to an argument about mismatch effects being important. These papers here are sort of building on this idea that maybe the reason we don't see completion effects is because there are mechanisms that allow even weak students to complete at good universities. And so Peter got in a lot of trouble, actually, with the president of Duke University for sort of pointing out that minority students who come in saying that they want to do STEM majors end up differentially sorting into easier social science majors, but they all finish, right? Or at least they don't finish any differently than anybody else. I'm not sure why that's controversial. It seems kind of obvious to me, but these papers are doing that. They're sort of focusing on these mechanisms by which we would not observe completion effects of mismatch. This is the paper that sort of scooped our Determinants paper. They do a similar analysis using different data and come to similar conclusions. There's also international literature, which I won't try to summarize here for reasons of time, but some of those papers are quite nice as well. Okay, so what are we going to do? This is probably the headline thing. We're going to try to estimate the causal effect of academic match using a nationally representative sample from a recent cohort. That has not really been done before in the literature. We are going to, because of our inspiration here, right, to go beyond just do you complete or not, we want to look at a bunch of outcomes. Some of them are mechanisms, like transfer, and we are going to look at college major, although I'm not going to show you that today. And we want to look at labor market effects, and that's going to be part of our value added relative to the literature. So we can't do too recent a cohort. We have to wait for them to be far enough out of college that they actually have kind of, they're all doing their earnings thing now. That'll be new relative to, well, I was talking to Lance today. Lance saw a version of this without the earnings. That is a new thing. We will argue, I will make the case that our measures of student ability and college quality and match are sort of superior for various reasons to those in the literature. And you can also think of this, less importantly, but I think not unimportantly, as a replication and extension in a broad sense of the earlier work that I did with Dan Black. We don't write down a formal model in this paper. We actually spend a bunch of time at the beginning of the Determinants paper thinking about formal models. Ultimately, we decided that we didn't have a lot of value to add relative to just saying we're inspired by these papers. And that's kind of how we think about the problem. We think it's quite possible to have causal effects of academic match or academic non-match in a world where students are rational, if it's also a world where they're not very well informed for various reasons. And I think the literature suggests strongly, and I'm going to make this case later on actually in arguing for the identification strategy, that we are in such a world, that there's a lot of misinformed students, and that those misinformed students are generating variation in college quality conditional on ability that's unrelated to stuff. That's just sort of random. So we imagine forward-looking rational students with heterogeneous information, maybe some experimentation. I always like this paper. I think it's undercited. Experimentation paper. There's lots of heterogeneity in the budget set. If one wants to go, and we may do this in a subsequent paper as well, down the route of trying to find instrumental variables, there is a lot of variation across states in the set of qualities that are available, in the prices and relative prices that are assigned to the colleges of different quality, and in some cases, specialized state loan and grant, Project Hope, yada yada, or Hope scholarship programs and stuff like that. Plus, of course, people have lots of non-academic concerns. Why did I go to the University of Washington for my undergraduate? Pretty much I went there because I wanted to go to football games with my dad. It turned out they had a really good computer science department that I got a degree from, and a pretty good economics department, it used to be better than it is now, that I got a degree from. Worked out okay, but really, truth be told, it was to go to the football games with my dad. So there you go. That's the kind of variation we want, in a sense, is me going to Washington for the football games. Analyst Y97, we're going to use the Black and Hispanic oversamples. We're going to use the sort of baseline weights to deal with the oversampling and a little bit with non-response conditional on observed variables. The weighting is not crucial to the results that we get here. Using oversamples allows us to have a much larger sample size. These guys are making their college choice around the turn of the millennium. So again, recent, but far enough back that we have earnings now. And this is good data, right? The NLSY, and I'm supposed to probably rah-rah the PSID now that I'm at Michigan, and the PSID is good too. But the NLSY has done a particularly good job of maintaining response rates over the long haul in a panel data context. So response rate's still around 0.8, which is pretty good for this kind of enterprise, as generally response rates have been falling, which is a problem for the research enterprise. Okay, let me tell you about our measure of student ability. Our measure of student ability is going to be based on the Armed Services Vocational Aptitude Battery, or ASVAB. Both NLSY cohorts took the ASVAB. The military pays the NLSY to administer the ASVAB. It pays the students to take it. They get $75 because they use it as a national norming sample, right? Everybody else who takes the ASVAB is trying to get into the military. That's a selected sample. People in NLSY are a national sample, so they use it to norm the test. We're going to follow these guys here, suspicious all to be sure, and take the first principal component of the underlying 12 separate ASVAB tests. And then we're going to rank students by their percentile in the age-adjusted first principal component. And it turns out that that first principal component loads on what we're going to call the SAT-like parts of the ASVAB. So the ASVAB is trying to do a couple of things. It's trying to figure out whether the military wants to let you in. And it's also trying to figure out, if they let you in, what they're going to assign you to do once you're in the military. So it has parts that look like the SAT. It has some parts that are timed, right? So how many multiplication problems that are simple can you do in a given time period? And then it has some sort of obviously vocational parts that are things about like trucks and electronics. And the first principal component loads on the SAT-like parts. The second principal component loads on the timed parts. And we're going to also include that as a conditioning variable. There is a paper by Karmat Sigal, who argued that there was a concern that people were throwing the test because they have no incentive to do well on it. We didn't find any evidence of that. We went looking. Now, we just looked within the people who touch a four-year school. So it may be that some of the other people are not really trying on the test. Right? The alternative is to use the SAT or the ACT, and those have problems of their own. The test scores that are available at NLS Y97 are the ones that are, you get a self-report, and you get a report from the high school transcript. So some high schools now put the SAT score on the transcript. It's not clear in either case which one you're getting. Students can take the test multiple times. That's very common now. It's not clear which one the school is giving you. It's not clear which one you're getting from the student. You'd kind of like the first take for everybody. Yeah. So there's reasons not to like that. Plus, those are both missing for a lot of people, and they don't agree very well when you have them for both people, when you have both of them for the same person. So we'll go with the ASVAB. Having said that, in our determinants paper, we do the whole analysis, or much of the analysis, also just using SAT. and qualitatively you get about the same stuff. College quality, we're going to follow my earlier work with Dan Black, and we're going to, again, take a bunch of proxies for college quality. So we're imagining that there's a one-dimensional thing, a Q star, a latent college quality, and that what we observe in the IPEDS data and in the US News data that we have is measurement error-ridden proxies for that underlying latent one-dimensional college quality index. And so we're going to take first principal component of the SAT score of the entering class, faculty-student ratio, that's calculated using just teaching faculty or undergraduate teaching faculty, average faculty salaries, and the rejection rate. That's the fraction of students who, whose applications are declined, I should say, by the university. It turns out, at least in the 79 cohort, we have not redone this all with the 97 cohort, but in the 79 cohort, once you sort of take any three reasonable proxy variables, the first principal component that comes out is correlated at like 0.95 or better with the first principal component of any other three reasonable proxies. There's a trade-off here between how many variables you include in the principal components analysis and the number of people you can construct the index for, because there's item non-response in the IPEDS. In the earlier work, we have used that to argue that we should just take the first principal component of 3 rather than 4 because it doesn't add a lot and you get more observations. What we do here is we just go with 4, and then for students who only have 3, we take the weighted average rescaled so the weights sum to 1 using the principal component weights. And so we keep the sample size that way. It doesn't make a huge difference, but it's nice to have more sample. These variables move very slowly over time, and so we're taking a cross-section of these college quality measures, even though we have 6 different cohorts in the underlying data. That does not make a difference. Then we take percentiles of the students using their quality distribution. Now, where did I say? Yeah, we take the percentiles of the colleges, sorry, but weighted by the number of students. And our idea is that if we weight our college quality distribution percentiles by the number of students, then we can have perfect assortative matching without violating capacity constraints. Right? So we have percentiles of student quality, we have percentiles of college quality. If we do the percentiles of college quality using student body size weights, then they just line up. Right? And so we can, in principle, have everybody be matched. Right? The student of ability 32 percentile could go to the college quality of the 32 percentile all the way down the line without violating anybody's capacity constraints. Now, there's a general equilibrium issue still lurking in the background of that statement, which is that one of the components of our college quality measure is the average SAT score of the entering class. If we reshuffled everybody around, those would change. So this is a sort of partial equilibrium, general equilibrium statement about our reshuffling. But there's a problem with the other, papers in the literature, which is that the typical mismatch measure that they use is they categorize schools, sometimes using the Barron's categories. And then they have some sort of model that predicts, based on where people actually go, what schools they're likely to get into. And then they take the sort of pretty school, but still not unlikely for each student, and say that's their match. And anybody below that is undermatched. Well, in that scheme, if you want to make everybody matched, you have to vastly increase the capacity at the better quality schools. And then you really run into this problem, because you're moving differentially low, below average students up to these better quality schools, making them worse. We think that's an unattractive feature of the measure, for example, in the Crossing the Finish Line book. And so we don't do it. All right, so this is just giving the standard measurement error model. And Black and Smith 2006 basically is a whole paper about why it's good to combine multiple variables if you think there's measurement error rather than just having one. Probably you knew that already. The treatment, in a sense, if we want to think about this as a treatment effects paper, is the first four-year college that you touch. Right? So if you transfer, and transfer is a big deal now, it turns out. If you transfer, we view that as an intermediate outcome. Right? It's just where the choice variable here that we're estimating the treatment effect of, or the production function that we're estimating, is about the first four-year college that you touch in the data, excluding people who take college courses when they're in high school, which takes some work to do in LSY. Yes?
Your critique of the other measure of college quality is really, you think of that as these as partial
Mm-hmm.
that critique is no longer critique. Is that right?
Yes, I think that's fair to say. But
I mean,
this is a very policy, parts of the literature are very policy oriented. And a lot of the people who are concerned in particular about undermatch want to move undermatched people up.
no, I understand you can't try to take their estimate.
Not everyone can be above average, right? It's really. I know you know. Okay.
I know that.
All right. So this is we picked one corner of one state at random, and looked at the colleges in that corner of that state just to give you some face validity of our measure of college quality. So these are Michigan is at 93rd percentile, Michigan State at 74. This kind of surprised me. Wayne State is the number 3 college in the Michigan system, but it's down at 36, and EMU, which is just up the road from University of Michigan in Ypsilanti, is at 28. So face validity.
You're limiting these to 4-year schools?
We are. We went down the road a little bit of 2-year schools in the Determinants paper. That was always something that audiences pushed us on, and also that referees and editors pushed us on. And the problem with that is constructing the college quality index for the 2-year schools. And Kevin Stang, our colleague in the Ford School, has sort of written a couple papers about college quality at 2-year schools. And because they're not selective, a lot of 2-year schools don't even report this. And so there's a sort of measurement problem. And this is 0 for the whole bottom quarter of the distribution of college quality, if not more. And that's kind of weird, so you kind of lost that. So it's awkward. We tried to do it in that paper. We decided to just back off from it in this paper. Maybe referees will make us do it, but that's not to say that 2-year schools aren't important. I think they're wildly understudied, but we are trying to do something about that.
Jeff, are there no private liberal arts colleges that dominate Wayne State in this?
No, this is not the whole list of colleges. I just want to show you some face validity. So I said, let's look at the colleges in southeastern Michigan and see if they come up in the right order. No. This is not top 4 at all, right? This is the 36th percentile of the distribution. So of the student-weighted quality distribution. So there are some private liberal arts colleges in the data, and some of them are up here, and some of them aren't very good, some of them are down there.
So with the 2-year, what happens if you just assume that the 2 years are the lowest quality and put them in at the bottom of your entire distribution? Does that help?
Well, if we're using a bin-based scheme, like in the Crossing the Finish Line book, then it's kind of easy, right? You can just stick them in the bottom bin. And indeed, what we found, to the best extent that we could construct this index for the 2 years in the Determinants paper, almost all the 2 years were in the lowest quartile of the distribution. We're trying to do a continuous number, right? And so it's not clear exactly where to put them in the continuous number, right? I agree for the bin-based scheme, that is an advantage of the bin-based scheme, is you can just stick the 2 years in the bottom bin. But even then, my sense is that the probability of finishing a 4-year degree if you start at Eastern Michigan and you want to get a 4-year degree is higher than if you start at Washtenaw Community College. And so putting them in the bottom of the bin is doing a little bit of a disservice, I think, to our student Locke Reynolds paper would argue.
I think you should think of the 2-year schools as qualitatively different.
Yeah, that's a good way to put it.
Consistent with Locke's paper, but consistent with, you could think about it as a Zimmerman paper.
Mm-hmm.
That's what he's doing. I mean, that's what he's doing, but
Yeah.
it's consistent with that notion. And we know relatively few people start at 2 years and finish 4 years.
Yeah, we used to have I will show you this table. So we used to have a bottom part of this table that was the 2-year starters. It's in the Determinants paper. This is the summary of college outcomes for our sample, right? So our sample is just people who touch a 4-year college before 2006, right? So people who we don't want to get people waited a long time. There's 2,406 of those. 27% graduate in 4 years, another 18% in 5, another 17% in 6 or more. So there's a lot of time to degree issues here, which John has studied in his work with Sarah and Mike. 35% leave without a BA. Only a handful of those are still in school at the end of our data, so most of them seem to be really gone. and then there's a fair amount of transfer behavior. All right, so a quarter of the students are transferring. If in the part of this that had the 2-year schools, the probability, and we were conditioning on a notion of wanting to get a 4-year degree, the best we could construct that in the NLSY, the probability of actually getting a 4-year degree ever from the 2-year starters was astoundingly small. It's scary. That's something we need to fix the 2 years somehow. I'm not sure how to do that. But. So this table of very small numbers illustrates the following point, which is that people sort to colleges of different qualities in kind of exactly the way that you would expect, right? So if we look at the highest college quality quartile, the students are sort of more academically or better on every measure of academic performance before college. Their parents are better in every way, you know, blah, blah, blah. And they come from better neighborhoods and da-da, and as you go down, they get worse. That's what that table shows you. So it's the sorting is what's been documented in the literature. We're thinking of match here as the coincidence between the percentile of the academic quality distribution and the percentile of the college quality distribution. Now, these are funny objects in a sense that economists are used to dealing with things that are closely tied to the real world. And these indices are a little bit more like the things that psychologists tend to deal with, in that they are these sort of semi-abstract constructs that are related to the real world, but not directly, right? So it isn't necessarily true that the optimal, in some one of any sense that you might define, place for a student at the 50th percentile to go is the 50th percentile of the college quality distribution as we measure it, right? Even if you believe we're in this one-dimensional college quality land, right, there is some underlying production function between the thing that we don't measure that we're trying to get at with our proxy index, the Q, and another thing that we don't measure, which is how sort of good the student is, but which we proxy with our ASVAB score. And that relationship between those two things can be nonlinear in arbitrary ways. And then what we have with both of our indices are what are hopefully monotone transformations of unknown shape of those true underlying things. And then we're kind of linking those. So there's a fundamental arbitrariness to this exercise that I find both intellectually interesting and also a bit frustrating. And it's not something that economists are as used to thinking about as psychologists are, because they often have things that are sort of completely defined solely by the measurement instrument, like internal locus of control, right? That's just the answer to a bunch of questions scaled up in a particular way. So the lesson I take away from that as an applied econometric sort of person is we want to be really flexible, and we're going to try to be really flexible in our specifications to allow for lots of nonlinearity in these relationships. And we want to be careful, about making bold claims about levels of things and focus more on patterns and derivatives, and we're going to try to do that too. There is a little literature on why you might or might not want match in this context. That has, I think, two main papers. One is this older Rothschild and White paper, and this is basically Becker's marriage model, which I guess actually I should attribute to somebody besides Becker. We'll call it Becker's marriage model. So if you have multiplicative spillovers between you and your peers, then it's optimal to sort kind of all the good students into one college and all the next best students in the next college and blah, 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 and order them that way. This paper here by people at Michigan, so these are former grad students at Michigan, that's my colleague Paul Courant, says that you can get to the same place if you just assume that it's more efficient in a technical sense to teach homogeneous classes. Right? And again, if it's more technically efficient to teach homogeneous classes, you want to group the students homogeneously. There's room for a lot more applied theory here, I think, than we have if we start to think about having multiple dimensions of match quality and so on. I'm not the person to do those papers, but I would be a happy consumer of them. This is the distribution of the difference between student ability percentile and college quality percentile where they match. I want to highlight a couple features of this graph. One is it's almost normal. We've drawn this almost normal looking line to help you think that it's almost normal. As a person who teaches undergraduate econometrics, you're always on the lookout for things that are normal. And there's a lot of mass at pretty large values. right? So there's a fair number of students who have differences of more than 50 percentile points between their ability and their college, both positive 50 and minus 50. Here is a table with the joint distribution that shows you that in a different way. So here we have ability quartiles from lowest to highest. Here we have college quality quartiles from lowest to highest. If we had perfect assortative match between students, academic match between students and colleges, everyone would be on the diagonal. If you look at the numbers, so here we have 11, 7, 6, 10, students are overrepresented on the diagonal. So there's a push towards match in the sense that we define it. But there remain non-trivial numbers of students in both of the off-diagonal corners. So down here you've got 5, 3, 4. That's 12. Up here you've got 10. Right? So that's like a quarter of students together who are at an extreme part of the mismatch distribution as we measure it. That's a lot. This is an empirically important phenomenon. And it's empirically important down here and up here. And I should note, a table just like this appears in the old Black and Smith table. Almost just like this appears in the Leiden-Strare paper. But nobody paid any policy attention to this until 2008. Yes?
Two things about this. One,
Okay.
in my understanding from the variety sources, including the Question Finish Line book, but whatever person is doing it, right, one of the things that if we think about SAT, not the test you're using,
Mm-hmm.
but that actually there's a more important determinant of how well kids do in college than that which it has to do with how well they did in high school.
Mm-hmm.
Which you can think has something to do with something other than intelligence.
Persistence or grit or whatever word you want to use. Yeah.
And certainly you probably have known kids that are remarkably bright and dope fiends or something like that. Anyway, but something like maybe you were too old for that, but whatever. But there's another dimension there, which is there's this other thing which is in both your measures, certainly in your student measure, there's measurement error.
Mm-hmm.
Both of those things would lead you to kind of a table which would be less than on the diagonal, but more substantive. I mean, there's a sort of a measurement part of this question, but there's a substantive part of this question. If you think there are dimensions of how well prepared kids are for college or whatever you want to think about that part that you leave out of your measure, how does that influence what you're doing? How do you think?
I will say a couple things. We did a graph like this in the Determinants paper where we used the student's SAT score as the measure of student ability, and we used the average SAT score of the entering class as the measure of college quality. That graph, or that table, has more weight on the diagonal, right? And perhaps that's not surprising, right? Because colleges observe the SAT, they don't observe the ASVAB score. You can think of that as perhaps a beneficial aspect of using the ASVAB score here rather than the SAT, I think, or not. So that's point one. Point two is we went down a bit of the road in the last paper of creating kind of a super index. So we combined the ASVAB components with the high school GPA and with the SAT score. And the correlation between the super index and our ASVAB index here is quite high. And high enough that it led us to think that we weren't going to gain a ton by going down that road. And I think we lose something in interpretability, perhaps. So I'm more sanguine than your question suggested that you were about not having that as part of our student quality index. Other questions? Yeah?
That students are like overmatched, is that then a sign of that screening doesn't work well enough at the universities? Or, like, I mean, I see why students go to lower universities. It's like the individual decisions.
Yes.
But, I mean, they have to get into these like more selective schools.
So I would say a couple things. Where was I going to head here? It would be really good to have, I mean, the LSY data are really rich. I'm going to put up our list of variables in a little bit and try to convince you that we have conditioned on an amazing array of different things that are likely to to at least give you pause before you dismiss our estimates out of hand as being based on the selection of unobserved variables. At the same time, the one thing that really would have been nice to have that we don't have is variables that would help us ask the question that you just answer the question that you just asked. So we actually went down the road of setting in a formal application to NLSY. This was like 6 years ago, to have them measure scholarship athletes in the data. Right. So in the U.S., as you know, we jointly produce semi-pro athletics and university education in a way that's puzzling to Europeans. And so some of the students of low ability who are at high quality schools are student athletes. And not just football and basketball players, but they may be athletes in other sports, in lacrosse or tennis or whatever. It would be nice to know who those folks are. Some of those people are probably people with some other talent, like musical talent or theater talent, who have gotten into specialized programs that have different admissions criteria than the rest of the undergraduate institution. At some places, some of those students are legacies. I don't think that's a giant part of the data, but at some privates, if your parents went or your parents give money or whatever, you can get in ways that are different than other people. It would be really cool to sort of be able to really pin down who those people are. No one that I know has been able to do that. The kind of data that you'd like to have would be hard to collect. John?
I think this is some guy in Princeton who had this data and got in deep trouble because he actually published a book on the subject.
Okay.
Somebody else. But anyway, colleges that do this don't want to tell you.
Yes, they don't want you to know.
That's one thing. But the other thing, isn't by construction the way you're constructing the indexes, if they're undermatched, they're over the overmatched?
The way we define it in the determinants paper is we have a fixed difference that you have to be before we declare that you are overmatched or undermatched of 15 percentile points. In that world, no, you don't have to have overmatched to go with the undermatched, because you can imagine moving the whole distribution and then you just get one kind of match. Here, when we're looking at any difference, then yes, they have to. That's sort of the flip side of respecting the capacity constraints.
Yes, yes.
Okay, so this is a student in the higher ed program at Michigan who took, actually she's done it twice now. She did it with Michigan administrative data and she did it with Tennessee administrative data. She sort of applied all of the definitions of mismatch in the literature and to a common data set. And what you find when you do that is that you can get any number you want, basically, by picking your definition of mismatch from published sources by authoritative figures, which is an unattractive feature of that literature, I would say. We did that. Okay, so what are we going to do? And my iPhone has run out of power, so I don't know what time it is now, and there's no clock. So 4:17. All right, so I think we're in good shape. We're going to do pretty simple stuff here. We have visions of doing more complicated stuff in future, but today we're going to do pretty simple stuff. I do remember very fondly one of my favorite quotes from Sherwin Rosen when I was in graduate school, somebody who used to hang out here at Hoover a lot. He supposedly, and maybe I actually heard him say this, quote, "If it isn't in the regression, it's not really there," unquote. I think that's too strong. But nonetheless, I think there is a truth to the fact that if the data aren't shouting about something, there's information in that. So in that kind of spirit, we're going to start out with a simple thing, which is what I always tell my students to do. We're just going to run probits and regressions depending on the outcome. We're going to report average derivatives. And then we're going to have a very flexible specification that includes interaction. So it includes main effects in college quality, includes main effects in student ability. It includes interaction terms between college quality and student ability. And then it includes a whole bunch of covariates that I'm going to show you shortly. We want to think about that as a partially linear model. Right, so that we are being non-parametric on college quality and ability by adopting this flexible polynomial and promising in our heart of hearts that when our sample gets bigger, we will add additional terms so that it is non-parametric. And then we are being parametric in the rest of the conditioning variables. That's how we're thinking about this. We did a formal testing strategy to remove the possibly manipulative hand of the researcher from this, to pick the amount of interaction terms that we included in our polynomial approximation. We also do a second version where we just use bins for quartiles of the distribution and interactions between those. Excuse me, in the polynomial version, we did a testing strategy. The testing strategy said no interaction terms. Right? So statistically, the data say you don't need to interact ability and quality. And we said, well, that would kind of be a short paper if all we do is do the test and then report that the data say that we shouldn't have any interaction terms. So we put in interaction terms anyway. Right? We disobeyed our statistical testing strategy. So we have ability times quality and ability squared times quality and quality squared times ability and I think ability squared times quality squared in there, even though the data said we didn't need them, right, to sort of make this interesting. Then I said we have the second semi-parametric specification. And we're also going to look not just at the statistical importance of those interaction terms, but we're also going to look at their substantive importance by doing predictions of outcomes with and without mismatch. So the outcomes with mismatch are just the observed outcomes. And then we're going to recode everybody's college quality to be the same as their student quality, predict their outcome again, and compare those two mean outcome levels as our substantive effect of college quality. This is something that Sarah Turner pushed us on quite correctly the last time that we presented this in front of her. Okay, what am I going to show you today in terms of outcomes? Mainly I'm going to talk about graduation in 5 years. Why we do 5 years, I don't know. The whole rest of the literature does 4 and 6. Before we send this off to a journal, we'll probably do 4 and 6. For the moment, we're doing 5. We'll look at transfer up and transfer down. We're going to define up and down as 5 percentile points in terms of the college quality ranking. If you do it as 0 percentile points or 10 percentile points, it doesn't change the qualitative findings. And then perhaps the most interesting thing today is effects on earnings. And we're going to do earnings all the way through starting with the year you start college. So we rearrange time to be relative to when you start college, and we look at earnings in pairs of years. This is kind of our trade-off between fineness of interpretation, which we'd like to have every year or every month or every quarter or something, and the fact that earnings are a noisy outcome in this population. And so we want a little bit of precision, and so we take averages over pairs of years. So year 0 and year 1, year 2 and year 3, and so on and so forth. When we finally get ready to send this to a journal, which should be this summer, we're going to look at major category. That's really important so that we are sort of addressing the Peter Arcidiacono literature. We're going to look at 4 and 6, and I think we're also going to try to look at debt as an interesting outcome, since student debt, as you may have noticed, is in the news as well. And we actually know something about it in the endless Y data. So I think that'll be interesting. Question? No?
Jeff?
Yes?
Since you're leveraging the richness of the covariance, I was wondering if you thought about and perhaps rejected some type of bounding procedure like the Altanji et al.
That is also on the list to be the next paper, along with the going after Dale and Kruger next paper. Yeah, I really like the Altanji Elder Tabor stuff. So for those who don't know, basically, the simplest way to think about it is in the context of the bivariate normal selection model, and basically in the context of what some would call the Heckman model. Well, I try to distinguish between the estimators and models. Heckman called it that. Yeah, he's one of, but now he calls it the classical selection model. Is what he calls it now. And no one is more critical of their own old work than Jim. I will give him credit for that. In terms of so that's the model where you have a normally distributed error term in the outcome equation, a normally distributed error in the treatment equation, and some correlation between the two. Typically what you do is you try to have an exclusion restriction in the participation equation or the treatment equation that identifies the model. And out of that model, you get an estimate of the correlation between the two error terms. It is an estimate of the magnitude of the selection on unobserved variables. Another way to think about it, which is what Altanji Elder Tabor do, is just fix the value of selection on unobserved variables at different correlations and see what that implies for the resulting treatment effect estimate. And that is something that we have in mind to do here. It'd be if you sort of took the framework of the Light and Strayer paper, which is a very much kind of 70s discrete choice kind of setup, you could very easily modify it to do the Altanji Elder Tabor thing. And I think that'd be a really interesting exercise. I'm giving away topics here. And if you're faster than me, you could go do it. And I'm not very fast. But yeah, I think that'd be really interesting. And that is also on our list of things to do, probably in the context of trying to do an instrumental variables analysis as well that exploits these cross-state differences in the extent to which prices are subsidized, and the quality gradient of prices, and so on and so forth. I think we'll end up getting more out of the Untitled Chapter than we will out of the instruments if we do it. Yeah, I will let Nora know, and we'll consider that when we're ordering the next paper in the list. We've also talked about going down more the road of some of the stuff that Jim has been doing recently with sort of more formal measurement error models, building on this kind of psychology tradition. And indeed, we have had a couple meetings for a 4-author paper with a couple of more recent Heckman students to join the old Heckman student and the Heckman grand student in that. But that it turns out is not going to happen this summer. That was on the docket for this summer. There's lots to do here. I think this is still a literature with lots of open possibilities. Other questions, comments? Okay. Identification strategy. So we're going to assume selection of observed variables. We're going to estimate these mean partial derivatives. As you'll see, we have this nice table format that I actually borrowed from a dissertation by a guy at a South African university that I was the external reviewer for. That a really smart guy, actually, called Muller. We're also going to do this, which I tend to blame on Heckman and Navarro to make it sound better, I guess. But it's not original to them. They just sort of talk about it in a serious way. There's a casual notion in the literature that if you're doing a selection on observed variable strategy and you sort of group your covariate sets from the ones that you think are most likely to be really important to getting rid of bias to sort of the least, and you add them sequentially, if the estimates stabilize, that is suggestive evidence that you have solved the selection problem by doing selection on observed variables. Emily Oster has a paper, 2013 NBR paper, where she points out that strategy is really only compelling if the additional variable sets actually capture residual variation in the outcome, right? So that you need to look at the R-squared value when you do this and make sure that the new variables that don't move the coefficient any farther do explain part of the outcome, or you really haven't done anything epistemologically. We're going to do that exercise. It is not definitive. There can always be some other unobserved factor that is orthogonal to all your included covariates that is still problematic. But given the richness of our covariate set, I think it's, again, it's not definitive, but I view, there's a hierarchy of evidence crowd who want to say, okay, every random assignment study is better than every RD study, is better than every different diff study, or is better than every IV study, is better than every different diff study, is better than every selection of observed variable study, is better than every before-after paper, is better than every theory paper. Treating theory as a way to get estimates of empirical parameters here, right, and not to provide insight. My view is that that's probably how the means line up in terms of compellingness of causal quality or quality of causal evidence, but that there's a whole lot of within identification strategy variation in quality, enough that focusing on the hierarchy of evidence is misleading at best. And so, I'm quite comfortable saying that many selection on observed variables papers are not very good. I think this one is good. I don't want to overclaim. If we had an experiment that randomly assigned people to colleges of different quality, that'd be great. We don't, and we're not going to anytime soon. So the fact that we don't have an experiment does not make our estimates more true. But I think also, this is a substantively important topic, and I don't think economists should walk away from substantively important topics just because there's not an experiment or an RD. I think that would be a bad thing for our profession to do. I think I'm talking to the choir on that. But anyway, so here is really small print. I apologize for this. We're doing just-in-time delivery this week, and this is our list of covariates. Let me just kind of highlight a bit of what we have. We have our student ability measures we've already talked about. We have a whole bunch of measures of sort of socio-emotional skills. So respondent had sex before 15, respondent intentionally destroyed or damaged somebody's property, respondent stole something, respondent suspended from school, respondent held back a grade. We have demographics. We have family characteristics, a number of other children in the household if you believe in the quality quantity model. We have family income. We have family wealth. It's not measured really well in LSY. That's not a strength of the data set. We have the parents' education. We have I don't think we do parents' occupation in this. We have neighborhood characteristics. We have census region. We have stuff from the census tract level because we're using the restricted access data that also gives us what college you went to. So Nora's doing all this in windowless rooms at various universities on computers not connected to the internet. We have features of the available college options in the state. Now, some people, maybe us, would want to think about using these as instruments. Our concern is that things like having a match, an academic match college nearby may also, right, if you think about the sort of CARD 1995 distance to college instrument paper, why aren't we using that as an instrument? Our concern is that that may partly be a proxy for living at home while you go to college, and we're concerned that living at home may have its own treatment effect. There is, I think, a little literature on that I've never managed to uncover. That's another thing that would be good to write about, actually, the treatment effect of living at home or in the dorms. Blah, 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 blah. And then for the last set, our main estimates don't include these. But the last set of estimates in this exercise about the coefficient stability are also going to include things like BMI. Right? We're getting every possible covariate fad in here. Religiosity, extra classes while you were in high school, having a computer at home, blah, blah, blah. So we got a lot of stuff. For a selection on observed variable strategy to succeed, you need two things. One is you need to have all the covariates that are correlated with both in a binary treatment effects context, the untreated outcome and the treatment choice. I think we've got a lot of stuff. I don't want to say we have enough, but I think we have a lot of stuff so that our estimates are at least meaningful. The other thing you need to have is you need to have variation in treatment choice conditional on all those x's. Right? Otherwise, you have a support issue, as it's called in the treatment effects context. So here I want to talk about where that variation comes from and why I think it's often plausibly exogenous. So one set of things is sort of all these features that I talked about as instruments. Right? In a sense, selection on observed variables still has instruments. It's just they're not observed and included in the analysis. But they're what's out there lurking around, creating variation in treatment choice, conditional on the observed covariates. That's how you get a common support, is you have instruments lurking out there that are varying treatment choice conditional on the observed covariates. Some of those are institutional. Some of them are these other reasons why you might pick a low-quality college or a high-quality college, like I did the football games with my dad. And then the others are all information-related. So unfortunately, Eric left before I got to cite his paper. But there's a whole kind of genre of literature on, whoa, those parents and guidance counselors, they're messed up. They don't know what they're doing, and those students. And so there's this whole literature on the one-offs, and they don't get good information, and blah, blah, blah. And so they often sort of don't go to a college as good as they could get into. This is good students at high schools that don't usually produce really good students. There's the Roderick et al. Qualitative work that's very compelling. I watched her present this at a conference one time. So this is the Chicago Consortium stuff. They followed around all these low-income students in Chicago as they went through the college selection process, and they report them choosing colleges based on how nice the greenery is and all kinds of horrible things like that. You know, they talk to the counselors. The counselors are clueless. Yeah, John?
Stanford is trying to do this very thing today.
Yes, it is. You're right. It is recruitment day for the undergrads here. Mandy Palace, number of free number of scores to which you get to send your ACT score for free matters for where you end up going to college. That's kind of crazy. And then Eric et al. On the FAFSA stuff. So I think there's credible evidence that because of informational issues, that there's a lot of behavior that is essentially unrelated to the thing that we are trying to study here, that leads to variation in college quality conditioned on all observed characteristics. All right, so maybe you don't even buy all that stuff. And I haven't yet shown you the coefficient stability stuff, but that's coming. How bad could the bias be? Well, I guess my prior. So this is, I think people should reveal their priors and talk about what they think the sign of the bias would be and what they think the magnitude might be. So, and here you go. This is your suggestion right here. There it is. Omitted variable bias, I would think, would lead to upward bias in the effect of college quality. That would be my prior. So we're overstating the effect of college quality. That means we're going to understate the effect of overmatch and overstate the effect of undermatch. As you will see, we are not going to find any effect of undermatch or overmatch. So you would then have to believe that overmatch is good and undermatch is bad. We're going to do this sensitivity exercise that I mentioned. You could also think about measurement error, right? I tried to convince you earlier that our measures of student ability and college quality have less measurement error than other measures that are used in the literature. That does not mean that they have 0. And in a loose kind of classical measurement error sense, and there's no particular reason to think that the measurement error would be classical, but in a loose classical measurement error sense, that would lead to attenuation bias. And that's less effective A and Q. And then that's our future choice stuff. All right, so here's the table format that I borrowed from this guy Muller. Probably he got it from somewhere else. So we're looking at average derivatives. So average derivatives of the outcome with respect to A, evaluated at different points in the distribution of Q. And we're looking at average derivatives of the outcome with respect to Q at different points in the distribution of A. And we have graduate within 5 years, enroll in graduate school, transfer to a higher quality college, transfer to a lower quality college. Somewhat easier to see are these graphs, which Nora made because I no longer had them. This is, some of your skills atrophy as you become a professor, and making graphs is one of those skills. Unfortunately, I wish I had this skill still. I used to know how to do it. Maybe this summer I'll relearn it. So here, this is probability of graduate in 5 years. These are college quality percentiles. And then we have 3 lines here for the 25th percentile of ability, the 50th percentile of ability, and the 75th percentile of ability. And I want you to take away, I guess, 3 things maybe from this graph. The first thing is all these lines are upward sloping, right? That is the quality main effect. Right? For students at all 3 of these levels, which are widely separated in the distribution, you can do this with 90 and 10, and they are also monotonically increasing. We switched to 25, 50, and 75 because we're a little concerned about the stability of the estimates at 90 and 10 because we're doing these polynomials, and polynomials often do weird things in the far reaches of the distribution of the data. So these are all upward sloping, right? Everybody's better off going to a better college. And they're roughly equidistant all the way along the distribution. That's what no mismatch means. No mismatch means that the effect of college quality is the same at every level of ability. That shows up in these graphs as the lines being the same vertical distance apart over the whole distribution of college quality. Not exactly, to be sure. Maybe that's our polynomial approximation. Maybe there's actually a little bit of departure from no mismatch. But certainly this does not scream out mismatch is really empirically important for completion. Now, we kind of already knew that from the literature, right? But we're finding what other people found in that regard. This is graduate school, right? There's a little bit of stuff happening out here where you get up into the upper reaches, and there seems to be more of an effect of being at a top 20 school on lesser ability students going to graduate school than lower ability students. Though if you look at the statistically, not there. And you interpret the statistics incorrectly, as the literature usually does. Here's the transfer behavior. So we do find behavior consistent with the mismatch hypothesis in regard to transfer in ways that are this is a little weird here, but this crossing thing. But again, if we had standard errors on here, you wouldn't be as bothered by that. But basically, students who are at high places transfer down, students who are at low places transfer up. That's not surprising. There's a fair amount of just parallel transfer as well. But the students who are differentially likely to transfer are students who are badly matched. So at low quality schools, high ability students are more likely to transfer up than middle or low ability students. At high quality schools, low ability students are more likely to transfer down than high or medium ability students. So on that dimension, and in ways that are perfectly reasonable, you get effects of mismatch, and they operate in ways that help avoid having a completion effect, right? So the overmatched student doesn't give up. They move down to a lower school and finish there. So that's partly a mechanism story. Earnings. So we're just going to highlight 2 of the years here. This is years 2 and 3 after the start of college. So many of these students are still in college. This is years 8 and 9. This isn't as obvious as the picture that we had for college completion. I think there may be something going on here that we just don't have enough power to detect, although as you'll see when we do the prediction exercise, substantively it's not all that important. These are always monotone. They are not parallel. Here, you've got a lot of things going on in the first few years that are kind of interesting. So people of all abilities have lower incomes at high quality colleges, presumably because they're getting more, either because they're getting more financial aid or because it's just harder to combine work with being at a high quality college. And so they work less. But part of what is happening too is that students at lower quality colleges, some of them will have already dropped out by years 2 and 3, whereas the students at the high quality colleges will not. And so the reason that you see more earnings at low quality colleges for all these groups are combining a couple of things, kind of several things: the financial aid, the ease of combining work and school, and the higher dropout probabilities at lower quality colleges. So the no mismatch effects are important for earnings. That result is after sort of people would mostly be done with college, so years 8 and 9. Let me go back here. This is no, not yet. So the table gives all the years. I just want to highlight the p-values here. So I showed you 8 and 9. We're actually on the margin here statistically of rejecting the null of no mismatch effects in the statistical sense, where p-value is 0.05. You will see that our sample size is declining, right? Because some years of the NLSY people are not old enough to have a year 10 and 11 yet. The statistical significance goes away here, so we don't overemphasize this. But so I don't want to say it's 0. But I do want to say that the data do not shout out, or maybe even say in their indoor voice, there is a lot of mismatch here. I don't think they necessarily say there is 0 either. But relative to the amount of policy enthusiasm, those pictures and this table look to me like not much. This is the table of predictions. So this is the actual outcome. This is when we resort everybody and predict their outcome if their college quality percentile matches their ability percentile. And this is what you get if you miraculously send everybody to a 90th percentile college. And what you see in terms of graduation, right, the effect is 0.5 percentage points. In terms of earnings, it is about $400 on a base of 27,937. So our point estimate isn't 0, right? There is some gain in average earnings from assigning everybody to a matched college as we define it. And again, there's a whole lot of general equilibrium stuff here that we're ignoring in this calculation. That's not a very big number, right, in a substantive sense. So whatever you think about the statistical sense, this is not a very big number in a substantive sense, right? This is 8 to 9 years after. Not surprisingly, given what I've told you up to this point, everybody looks happier and better if we could send them all to a 90th percentile college quality. Let me show you the stability exercise. I'll show it to you for earnings, where it is a bit less strong, actually, I think, than it is for the completion. So here we're just looking at earnings 8 to 9 years after you start college. The columns now, right, so this is, before the columns were different outcomes. Now the columns are different covariate sets. So we tell you about the covariate sets here. The first column is just ability and quality in a flexible polynomial. The second column adds the additional ability measures and socioeconomic skills. Third column adds demographics and family characteristics. Fourth column adds neighborhood characteristics and local college options. And the fifth column adds those additional covariates which have not been included heretofore in the paper. And coefficient stability means that you ought to see that when you look across, that the numbers seem to be settling down. And I would argue that that is indeed what you see. The biggest change is, not surprisingly, adding in these initial variables. You get fairly large changes in some of these things. But if you compare these two columns, not so different. And this is not a trivial increase in the R squared, right? We're going from 0.142 to 0.153 with that last set of variables, which were kind of obscure stuff like BMI and religiosity and blah, blah, blah. They're not moving the coefficients very much. They are moving the R squared. Again, I don't want to, I'm trying to build a case, right? This is a preponderance of the evidence, not beyond a reasonable doubt. I'm trying to build a preponderance of the evidence case here that our estimates are compellingly causal. Not zero error, but worth paying attention to and informative. And this is one piece of that case, which is that as we increase the covariate set, the shape of this flexible form in A and Q settles down. Okay, strong quality main effect, just like all the rest of the literature except for Dale and Kruger. Moderate ability main effect, cannot reject the null of no interactions for many of the outcomes. The ones where we can reject the null of no interactions like transfers, things seem to behave in exactly the way that you would expect, and they help us understand why there's no mismatch effect on completion. Chingos has what I think is one of the nicest policy papers I've actually ever read. It ended up as a chapter in a book. He does what we just did, this exercise of sort of estimating a model and then predicting with and without mismatch. His model is much simpler. His definitions of ability and quality are, we think, inferior to ours, blah, 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 blah. He's doing a policy paper, sort of a much more back of the envelope enterprise with a different data set, exactly the same result. And he sort of says, you know, looking at mismatch is not looking where the action is in terms of helping low-income kids do better academically. Concluding remarks. This may be the first time I have ever finished a talk before the allotted time, so feel free to interrupt and prevent that from happening. But there is lots of mismatch in both directions in the NLS Y97 data. Quality main effect, very important. Mismatch, not so much, except on the transfer outcome and maybe the graduate school outcome. We're looking forward to the major results. We will have those this summer. There's also this literature on law schools. So there's this guy Sander at UCLA. He has sparred in the literature with Jesse Rothstein and co-authors. It's not a friendly literature, I would say. I think that's fair to say. I think law school is different in the following sense, that my explanation for why there's no completion effects in undergraduate education is that universities are very flexible institutions with many paths. Law schools are not flexible institutions with many paths. Law school is a much more homogeneous. You can't really easily say, I'm going to take more time to finish. You can't really easily say, I'm going to take an easier major. I assume there's some variation in what you do in law school, but I think it's a lot less than in the typical four-year university. So I don't think that our findings necessarily imply that there's something wrong with, or something right with Sanders' findings of important mismatches effects in law school. I think law schools are different in ways that would lead you to think that you could possibly find mismatch effects there when you don't find them in undergraduate context. Policy, I think I have come to agree with Matt Chingos on this. You know, mismatch is not where you need to be directing your attention. I think where you need to be directing your attention is figuring out what to do with the people at the directional schools who spend a bunch of money. Maybe it's taxpayer money at public schools. It's student loans at private schools. And then they don't finish, and money has been wasted. And figuring out how to deal with that would be very useful. There's a problem in this literature that all the people who write these papers are not at these schools. They're all at places like this. And I think oftentimes our intuition from places like this doesn't generalize well to places like Eastern Michigan. I'm not quite sure how to deal with it. Finally, I think another direction for the literature, and maybe economists are not the people to do this, and maybe they are, is to worry a bit about other forms of match quality besides academic match. I read this book, Paying for the Party, by my Michigan colleague Elizabeth Anderson and a student of hers. It is a ethnography, essentially, although there's some quantitative work in it, of students in one floor of one dorm at the University of Indiana. And it's very interesting because they chose Indiana. I didn't realize this, but they make a bunch of money catering to East Coast students who don't get into better schools on the East Coast and who want to go to a school with an extensive Greek life program. And the way it's set up at Indiana, even if you're going to go down the sorority and fraternity path, you spend 1 year in the dorms and go through rush while you're in the dorms. So this dorm floor mixes a whole bunch of people with money from the East Coast who want to go to sororities with a bunch of people from little towns in Indiana many of whom's families have never been to college before. That is a very interesting cultural juxtaposition. And it is very hard on some of the kids from rural Indiana. and that is documented in this book. And you know, these guys all have the same test scores, right? This is not academic match. This is a different thing going on that is still important for the academic success of these sort of first-in-the-family college students in this environment. I found it a very moving and very interesting book. And it really, you know, the economics literature hasn't paid any attention to this sort of mismatch. The same thing is described in fictional form in Tom Wolfe's book, I Am Charlotte Simmons, which is about a one-off, essentially, to use Sarah and Caroline's term, a one-off who ends up at Duke and experiences the same kind of cultural juxtaposition. Questions?
I just had a question about the quality ranking that you constructed.
Mm-hmm.
So I think you said you made it into percentiles.
Yep.
But from the principal components, you would get something that was more on an interval scale, I think, right?
You get a number, right? You get a weighted average of the variables that you input into the principal component analysis.
Yeah, so I was just wondering, so from Carolyn and Chris Avery's paper, they're worried that some of the measures and the measures that you use as well in the principal components are something universities can gain.
Yep.
Do you look to see whether the rankings that you constructed, the principal component values that you constructed correlated well with the sort of the theta values that they estimated in their QJE paper for the tier 1 schools?
I did not do that. That would be a nice thing to do. What we did do, so I am completely on board with the gaming stuff, right? So when I was at Maryland, where I was before Michigan and after Western Ontario, Maryland did a policy change where they admitted fewer first-year students and took in more transfer students. Part of the reason for that policy was to game the average SAT score of the entering class quality measure. So yeah, schools do this. So one response, a kind of flip response, but also I think not an untrue one, is if all the schools do it and all do it equally well, our relative rankings are not going to be problematized by that. And I think there's something to that response. A second response is, as I mentioned, in the 79 cohort stuff, we did this sort of extensive analysis using a wide variety of proxies of first principle components constructed from different combinations. And those all give about the same information once you've got about 3 of them in there. And so I think that also reduces my concern about this issue a little bit. But I should look again at this paper and see if there's more that we could do on this dimension. Rick?
I want to come back to the measurement error thing. My comment is sort of along the very last line there. Say there's different dimensions other than academic things, like athletics and music and all kinds of things. The 2 places where your evidence is strongest on mismatch are the 2 places where academic things are the prime mover, transfers and graduate school. And the other things are not as well, you don't see much. And that's consistent, at least, with other dimensions of this measurement of quality for both students and universities.
I like that framing. I would say Elizabeth Anderson, I think, might dispute that a little bit, right? So some of her first-generation kids end up transferring down.
I mean, it's not
Yeah,
an argument.
yeah.
Basically,
Yeah.
that there are other dimensions.
No, agreed. I like that framing. Yeah.
So I understand the technical challenges with the community colleges, but I'm a little concerned that it's missing a large part of the picture in the sense that it's something about like 40%, I think, of high school graduates are in that range roughly go to community colleges. And the argument is that's where a lot of the mismatch is occurring. And there's a couple of those recent ones. There's the Josh Goodman paper in Georgia, and then I don't think there's a paper out, but Carolyn Hawksby at least has been studying a program in New Jersey where I think the top 10% of students get to go and is finding dramatically negative effects. So it just seems like there is a margin, sort of community college, even to sort of less selective or more selective four-year college. We were seeing really dramatic negative impacts. At least on bachelor degree completion, we don't know wages. And so I guess it just seems like part of the story is missing in terms of where the mismatch is occurring.
In my sense of the Texas stuff, of course, a lot of the movement in Texas is not from 2-year to Texas or Texas A&M. It's from directional schools to Texas and Texas A&M, and maybe that you're saying that's not the problem. one other response would be that a lot of those, some decent fraction of those kids who start community college are not intending to get a 4-year degree, right? Some of them are doing occupational things. But even if it's 20% of students who are starting there with the intention of getting a 4-year degree, it should be paid attention to. I mean, yes,
I understand the
hard to do. Yeah. John?
I think there's a confusion here, not your confusion, or at least I'm not sure what people who are pushing this line have in mind. Now, some of it has to do with this affirmative action issues. Are we letting, and you could pick on alumni kids as much as you could pick on ethnic minorities there.
Mm-hmm.
But, you know, or we, you know, that's the kind of one aspect of this. But there's another aspect of it, I think, that, you know, certainly I would have brought the interpretation in Carolyn and Sarah's work, is if you send kids who are perfectly capable of doing better, of going to a selective school, they may be better off both because it will be cheaper, and they'll be better off because they do because there is a quality dimension.
Mm-hmm. Mm-hmm.
So in this sense, I'm not sure what your question was getting at, but if you ask people, you know, I think if you ask Jeff whether he thinks that if you send a kid to a 2-year school, they're likely to do just as well as if you send them to a 4-year school, his answer would be, God, no. The evidence all tells us that's not true. So that's, I don't know whether that's a there's kind of in another version of what you were saying is the overwhelming dimension of what's going on here is quality matters.
Mm-hmm.
And so in that sense,
Yeah, that's the headline message.
A parent who wants their kid to go to Michigan rather than Eastern Michigan is absolutely right.
Yeah.
You're kind of not so good at, you don't have so many people who have gone to Stanford, so you can't really say that a parent who could send their kid to Michigan or Stanford should be sending their kid to Stanford. But
Well, and that's going to be a pretty small distance on our
no, I understand.
quality index relative to.
That's the point.
Yeah.
That's my point there. It's only that. So in some sense, it's not, if you're thinking, well, the kid who goes to community college, that's a mistake because they would be better off going to a 4-year school if they could get in. I think all the evidence we have, Block, Reynolds, who did this on selection of observables, but the Zimmerman paper is basically 2 years versus 4 years. All that says,
Mm-hmm.
if the kid can get into a 4-year school, send him to a 4-year school.
Yeah, I agree with that. But I should look at the. Yeah.
So I'm really sympathetic to the results, particularly when you benchmark them against the kind of other policy alternatives we should be thinking about. Just play devil's advocate, try to breathe a little life into the mismatch.
It's got plenty of life.
Just for the sake of doing so. So I'm wondering about treatment heterogeneity across different types of institutions. And just thinking anecdotally here, I remember my time at Swarthmore, I was on this committee where we would sit around for a long day, twice a year, poring over the details of individual students' transcripts, just doing everything we could in the parlance of the time to walk them across the stage. And find them a major, find them a home, so they can graduate. And I'm imagining at other types of institutions, large public universities, there's just kind of I don't know this to be true, but I'm imagining there's kind of a buzzsaw where you hit a certain amount of credits with such and such a GPA, and you're bumped off campus on probation for a while.
But at least.
So there might be, I'm thinking about how that might interface with Mismatch. It might be at a subset of institutions where there are those types of mechanistic things that might push people towards extended time to completion or just dropping out entirely.
My sense, I mean, there is that kind of probation yada yada mechanism at Michigan, to be sure. But my sense is that there's also kind of a institutional early warning system that's designed to find people who seem to be at risk of going down that path and intervening with them. Right? They can't sit down and go over every student because there's tens of thousands of them. But my sense is that they try to use sort of statistical methods to locate the students that they should be doing that about, and make sure that they get some resources. I would guess that Michigan State has something like that too. I bet that goes somewhat down the distribution, maybe all the way down the distribution of four-year publics. I don't know. Probably not with the same faculty involvement and enthusiasm as at Swarthmore.
There was involvement.
Okay. I mean, another issue that nobody has brought up is the fact that there may be quality heterogeneity within institutions, right? That you know, at Western Ontario, where I used to be, right, we had, as they called them, departments of international stature, of which economics was one, and there were other departments that had national or perhaps local stature, and so a student at Western who went to one department could get a very different quality of education than a student who went to another department. I don't think most schools are quite as dramatically heterogeneous as Western Ontario was. But that's another exercise that remains undone because of the intensity of the work that's involved to do that, to try to measure kind of field quality at multiple institutions. There have been people who have studied this in Europe, right, in national contexts where you apply to a department instead of applying to university, right? They have a different scheme, and then there's sort of more information out there about department quality, and the department quality treatment is not clouded by the 2 years of distribution requirements that everybody's doing at the beginning. And they have found effects of department quality, conditional and institutional quality. Other questions, remarks? John?
I think it's worth thinking about that the difference, I suspect that your estimates are being driven more by the difference between Michigan State and Eastern as whatever it is. What was Weber's term? Whatever. I mean,
I didn't know Weber commented on the colleges in southeastern Michigan,
like,
but
I'm using those as a type.
yeah. Oh, okay.
Than they are between Swarthmore and Columbia.
Yes. I think that's absolutely true.
And they are having known people who went to Eastern, and people certainly went to Michigan, and people who went to Michigan State. The difference between the resources in every sense of the word that you get at Eastern versus Michigan State is like huge in the sense that there's no advising. Nobody seems to care. Your professor may be fired in the middle of the semester because they didn't have the money to pay him. They may bring an adjunct in the middle. I mean, it's a completely world different. So is that partly is the advising difference or that kind of thing, or you can't get into courses because they've been closed out and things like that, and does that then discourage people from continuing? I don't think we know in any real sense what's going on there. In that sense, I would support, you're telling us all to go and be ethnographers or maybe ethnographers.
Well, read. It was division of labor and specialization. I'm in favor of it. Read the ethnographers, right?
I'm very sympathetic to the notion resources and things like that, just a black box.
Mm-hmm.
But I'm also from completely anecdotal evidence, that basically there's a world difference between, say, Berkeley and Davis, and there's a world difference between Davis and was it Cal State?
Cal State LA or something, yeah.
Yes, and you're really in different universes when you go to those schools. And so that, I mean, that might be part of it. But I don't know whether that's a mismatch or that's a resource.
So we'll have one last question from Ken, and then we'll have food and drink.
Yeah, sorry, this actually speaks to the comment. I'm a little concerned that when you converted your first principal components to percentiles, that you've thrown away a lot of that relative differences between institutions and ability level. You've done this analysis using the actual principal factor loaded principal components that you're able to get. Because you're really kind of compressing that distribution when you make it a uniform ranking of percents.
But we are then being flexible in our functional form in the percentiles, which I think addresses that concern. Yeah. And I didn't put the results up, but we had this parallel specification with the bin indicators, which gives you the same qualitative conclusion.
I guess it is if you have somebody who's a 99 and a 98, but there's sort of relative differences quite far, that would be one speaking to.
Actually, I have a better answer for that too. So we, maybe it was Caroline actually who pushed us on this at NBR. We looked at how the underlying components vary with the percentile. And they vary in a sort of steadily increasing linear-ish way up to about the last 15 percentiles, and then it gets steeper. So it's not a wildly nonlinear mapping from the individual components to the percentiles. But that's a good question. All right, thank you very much.
Thank you, Jack.